Hey guys, and welcome to another video all about how to use systems of equations to describe and model some real-world situations. So, in this example, we're talking about a busy Saturday evening at the movie theaters, and Teddy the ticket taker didn't quite do his job as well as he should have. He was supposed to collect money and direct patrons, but he was also supposed to keep track of how many children's and adults tickets were sold. So he did count how much money he collected, and he counted the total number of tickets, but he forgot to count the individual types of tickets. So he forgot to count exactly how many child tickets he sold and how many adult tickets he sold. But here's what we do know. We do know that he collected a total of 133 tickets. And we do know that he collected a total of $1,087, and we know exactly how much each child ticket costs and how much each adult ticket costs. And what we're really wondering is this enough information to determine exactly how many children's tickets and adults tickets he sold that day? How many children and adults came to the movie theater? Okay, and we're going to do it step by step. So first, let's start with the fact that he collected a total of 133 tickets. Now, can we come up with a possibility of how many adults and children could have come? I don't know, we could have had one child and 132 adults, right? That would be 133 total tickets. We could have had, 20 children and 113 adults, right? That sums up to 133. We could have had 100 children and 33 adults, and that adds up to 133. We've come up with a whole bunch of different possibilities for how many children and adults could have come to the theaters. And how many possibilities are there? Well, a lot. If we were just wondering how many different combinations of two numbers add up to 133, we'd have infinitely many. But since we're talking about a real-world situation here, we couldn't have, for instance, 134 children and -1 adult. Simply wouldn't make sense. So there are going to be a lot of different options. So right now, knowing that there were 133 tickets sold isn't enough information to determine exactly how many of each type. Bummer. But what we can do is come up with an equation to describe all of the different combinations of adult tickets and children's tickets that should have been sold that night, given the fact that Teddy collected a total of 133 tickets. And note to self, the equation that we come up with here is going to be really helpful for a lot of different scenarios, right? He collected a total of 133 tickets. In other modeling situations, you're going to have situations where a total of blank happened, and it's going to be a very similar kind of equation, so do take note. And of course, if we're going to come up with an equation, we need at least one variable. And in fact, we're going to need two in this case. So let's let our two variables be x and y. I know, really original. So let's let x represent the number of children's tickets, or number of child tickets. And we're going to let y be the number of adult tickets. Now, I'm using x and y. You can use whatever variables you want. And I do want to make a note that in this situation, this is less of an input-output or independent and dependent variable kind of relationship. We just need two variables. And I'm going to use x and y because they're familiar, and that's what we use a lot, and maybe people feel more comfortable with that. But I also urge students who don't feel that they need x and y to use something other than x and y. I would use just random letters. Okay, so here's my claim, that however many children's tickets we sell, and however many adult tickets we sell, we have to sell a total of 133 of them. So when we sum these two up together, they should add to 133. So as long as the number of children's tickets and the number of adults tickets, as long as they sum up to 133, boom, we will have a scenario that works with the fact that Teddy collected 133 tickets. So that first piece of information gave us this equation. Awesome. Although, like we knew before, one equation with two unknown variables, there are too many combinations for us to determine x and y, or child's tickets and adult tickets. But if we can come up with another equation involving x and y, we'll have two equations with two variables. That's a system we could definitely solve. So that's kind of our next goal. So here we go. Moving on. So here's my question. If there were 9 adults tickets sold and 13 children's tickets sold, how much would Teddy have collected? We need to remember that a child's ticket cost $7 and an adult ticket costs $10. Well, all right, so if there were 9 adult tickets sold, I'm actually going to start with children. If there were 13 children's tickets sold, I would do 13 times 7 to find out that's how much money would have been collected from children, $13 a ticket. Sorry, 13 tickets, each of which sold for $7. And there were 9 adults tickets sold. Well, 9 times 10, 9 adult tickets times $10 each. That would give us the total amount that was collected that day. So 13 times 7 is 91, I think. Better be 91. 9 times 10 is 90 for a grand total of $181. So that would have been the grand total if there were 13 children and 9 adults who bought tickets. Well, okay, here's my question then. What if, now I'm going to just come up with random numbers, and hopefully we can start to see a pattern arising. So now what if there were 100 child tickets sold and 44 adult tickets sold? Well, of course the prices aren't going to change, right? It's still going to be $7 for a child's ticket and $10 for an adult ticket. It's just the quantity of each that's going to change. Instead of 13 children, it's going to be 100 children. And instead of 9 adults, it's 44 adults. Awesome. So in this case, I'd say, okay, well, the total ticket sales will be 100 times 7, which is 700. And 44 times 10 is 440, for a grand total of $1,140. So if we had sold 100 children's tickets and 44 adult tickets, well, we'd have a grand total of $1,140 worth of ticket sales. And I'm going to put this off in the corner, or just down below as well. And so hopefully we can see that. All we need to do to find our total dollars worth of ticket sales is you take the child's ticket price of 7, multiply it by however many we sell, and the adult ticket price of 10, and multiply that by however many we sell. But we don't know how many we sold. So let's make an expression for how much our ticket sales would be if we sold Y adult tickets and X children's tickets. Remember, we defined some variables before to represent the number of children's tickets sold and the number of adults tickets sold with X and Y variables. And my claim is that everything's going to be the same. If we sell X children's tickets, how much money are we going to get from those tickets? $7 times however many children's tickets we sold. Oh, so 7 times X. And if we sold Y adult tickets, well, we'd sell $10 per ticket times however many adult tickets. So $10 times Y. And what we do know, kind of making our way onward, is, well, this is how much we sell. If we sell X, this is the dollars worth of X number of child's tickets and Y number of adult tickets. Well, what we do know is that that total that we sold on this evening was exactly $1,087. So now we have another equation involving X and Y. So we've got two equations. I'm going to go drag over that other one we created as well, having to do with the total ticket sales, not how much they cost. All right, so now we've got two equations involving two variables, X and Y. This is a system. We know how to solve it. So let's go ahead and solve it. We'll be able to find from this information exactly how many children's ticket and adults tickets were sold. And I think the way to do it is using the substitution method. So what I would do, and I'm just going to copy these again, is I would take this second equation and I would solve it for X or for Y, whichever one is easier. I'm just going to subtract Y and solve for X equals 133 minus Y. And now I'm going to take that expression and I'm going to substitute this right on in to this first equation for X, yielding 7 times the quantity of 133 minus Y plus 10Y equals 1,087. These numbers may look a little nasty, but they're really not going to be too bad. At least I don't think so. So 7 times 133 is 931 minus 7Y plus 10Y equals 1087. Let's subtract on over that 931. Subtract that from both sides. And collect some like terms on the left-hand side. We end up with 3Y equals 156. And when we divide both sides by 3, we find that Y, the number of adult tickets sold, was 52. So there was 52 adult tickets sold. Okay, and if we want to find out how many children's tickets were sold, all we have to do is take this equation on up here. The number of children's tickets was 133 in total were sold. Let's take away the 52 that we know were adult tickets. And so the number of children's tickets were 81. So we should have sold 81 children's tickets and 52 adult tickets. We might as well just make sure that this works, right? We know that 81 plus 52 is 133. So that satisfies one of our equations. Will it satisfy the other? So if there were 81 children's tickets sold. Okay, so 7 times 81 is 567. I'm just going to make a little note to myself. 567. And 10 times 52 would be 520 for a grand total of 1,087. Amazing. Amazing. So what we did here is we took these real-world situation and these two pieces of information and used each of these to create a different equation involving these two new variables, X and Y, solve that system, and we're able to find out exactly how many children's and adult tickets were sold. If you want, you can also think about this with a graph, right? If you had created these two equations, you could have always put them in your graphing calculator and to see what the solution would be. And I just think it's really nice to get an appreciation for that as well. So a total of 133 tickets were sold. Right? We made the equation x plus y, the number of children's tickets plus the number of adult tickets, had to equal 133. And so here is a graph of all of the different combinations of tickets that would sum up to 133. Now, of course, there shouldn't be all these decimals and stuff because it's real life, but alas, what are you going to do? And they collected a total of $1,087. Well, here's the equation that we came up with. And this line right here represents all of the combinations of children's tickets and adults tickets for which there would be $1,087 collected. The only time when both this was true and this was true, boom, right when there were 81 children's tickets and 52 adult tickets.